Hello, these are the exercises for section 5.6 on random variables and probability distributions. So this exercise is asking us to find the expected value. So the random variable x is the number of houses sold by a realtor in a single month at the Sensum's real estate office. Its probability distribution is given below. Find the mean number of houses sold. So there's actually two ways to go about doing this, and we're going to do it both ways. One way is using GeoGebra, and the directions for GeoGebra are right above this. You also can go through and find the GeoGebra video to help guide you along. But what you're going to do is you're going to open up GeoGebra, and you're going to go to your spreadsheet. And you may have to adjust the windows a little bit so that you can see the spreadsheet. And I'm going to go here and I'm going to copy, go back to selection instead of drawing. And I'm going to delete this first. And then I'm going to copy and paste that over here into my spreadsheet. Okay. And then you go through and you highlight. So remember this X, this is, look at our data set. Our X is the number of houses sold. So there are some months where this realtor sold 0 houses in a month, okay? And there are some months that she sells 4 houses in 1 month, okay? However, they don't happen at all the same probabilities. So she sells 0 houses about 24% of the time. She sells 4 houses about 14% of the time. So we want to go through and find an average number so she can kind of maybe budget her whole year, right? Kind of figure out how many houses they sell on average, they can get a cost estimate, etc. So we want to go through and find the average number of houses given these probabilities per month for this realtor, okay? That's what we're going to be doing here. So we come here and we have our X's here. This is the number of houses that they can sell in a month. And then we have the P of X, which is our probabilities of selling those houses in 1 month. And you highlight them, and then you come here and you click this histogram and you hit the one variable analysis. So it goes and makes you a graph, but we aren't interested in the graph. What we're interested in is this statistics button. So you go here and you click the statistics, and this mean 2.35, that's going to be your expected value. So we come back over here, and my expected value is 2.35. So interpreting this, this would be something like the realtor is expected to sell 2.35 houses in a single month on average. Okay, so this is saying, okay, she's never going to sell 2.35 exactly houses because you can't sell 0.35 of a house, right? But remember, this is an average, so we're saying over the whole year, over her whole career, potentially, she's going to sell about 2.35 houses per month. Some months she'll sell 6 months, some months she'll sell 0 houses. 6 houses or 0 houses, but on average, she'll sell about 2.35 per month, okay? The other thing I want to teach you is how to do this by hand. And this is helpful because here you have actually a lot of X values. But if you only had like 2 X values or 3 X values, then by hand, oftentimes it's faster, okay? So by hand, we have this formula that probably looks a little bit math language heavy for you, but we're saying, okay, multiply your X by the probability of having X, and then this capital sigma means, and then add them all together, okay? So what this means is we're going to have 0 times 0.24 plus 1, because you do this X value times the probability of that X value times 0.13, the X value, which is plus 2, times the probability, 0.16, plus 3 times 0.21 plus 4 times 0.14 plus 5 times 0.01 plus 6 times 0.11. And if you go through and you do this whole computation, then you will still get 2.35. So however you do the expected value, whether by GeoGebra or by hand, you'll get the same answer of 2.35 as the average number of houses this realtor is expected to sell in a month. Okay. The second example is another type of expected value problem. So a life insurance company sells a $250,000 one-year term life insurance policy to a 20-year-old female for $20. For $200. According to the National Vital Statistics Report, the probability that a female survives the year is 0.999544. Compute and interpret the expected value of this policy to the insurance company. Okay, so these are very helpful to use a table to analyze them. Okay. Okay. So we have these 3 columns, and the first column you're going to think about the event. So what could happen to this female in the year that this insurance policy happens? She could survive, or she could die, right? So we're going to go through and we're going to find information on those 2 different events and use them to find the expected value. Okay, and this expected value of money to the insurance company. So this is going to be the money to the insurance. Okay, so if and this is going to be the probability that she survives or dies. So there are a couple of these things that are really easy to fill in. Okay, so we have that the probability that a female survives the year is this probability here. So we're going to just report this, and the event and the probability that she survives is going to be 0.999544. Okay, and if she survives, the company, she just takes her money and she doesn't get any money from the insurance. And so the insurance policy costs $200. So the money that goes to the insurance company is $200, and the probability that's going to happen is going to be, if she survives, is the probability. Okay, these other options are a little bit harder to figure out. Okay, so we're going to first use the complement rule to find the probability that they die, right? So it's only 2 events, either the female survives or she dies. So if she survives, we have probability. So that means that if she dies, it's going to be 1 minus the probability that she dies. This is just using the complement rule. Okay, if you do that, you get 0.000456. Okay, then let's think about what does the insurance company get or lose if she dies. Okay, so insurance, you buy in with your premium, and then if that event that you're insuring against happens, then the company then pays you money, right? So if the female dies, the insurance company has to pay this $250,000 to her family. However, the only reason why they even pay this money out is because she bought into the policy to begin with. So she paid that $200 to begin with, and then the company, because she died, lost $250,000. So that means that they lost $249,000 $1,800. They lost that much money. Okay, so here we actually only have 2 events and we have probability. So you could go through and do this in GeoGebra before, like this is the column A and this is the column B, and do it like we did in the last example. But since there's only 2, doing it by hand is actually really nice. So my expected value would be 200 times 0.999544, and then add that to a negative 249,800 times 0.000456. Remember, you do this event times probability of that event, plus this event times the probability of that event. And if you do this, you get $86. Okay, so let's go through and interpret what this expected value actually means. Okay, so if the insurance companies have a lot of people buying into their policies, then some people will die and some people won't die. So they'll be getting a lot of money from people who didn't die, and then they'll be paying out money to people who did die, right? So on average, remember what the value is the average if there's a lot of events happening. So in this case, this is going to be the average payout to the insurance if we have a lot of insurance policies that are sold. Okay, so the interpretation is if company sells many policies, the company will expect to make $86 per policy on average. Thank you.